So I'm very happy to have Theo Offerman here. We were colleagues in Amsterdam. Actually, he was sort of my boss. And yeah, Theo is a very talented behavioral game theorist, I would say. And he's working mostly on now on communication in games. So mostly on signaling, chip talk. He has also some papers on morality of market. But before he was working also more on theoretical aspects, such as auction theory, and he had some experimental work on reciprocity, on cooperation, and other aspects of other regarding concerns. So recently, he extended his work on communication in games by looking at AI mediation in this communication, and I'm very much looking forward to see what he will tell us. And so, yeah. Just a note, if you didn't talk to him, I recommend you to do that, because it normally has very insightful comments and suggestions for experimental design, or if you work with games, also some interesting suggestions how to look at the game, what are the properties of the game. Okay, so Theo, please.
Thank you very much, Ivan, for this very kind introduction. So this is joint work with Ivo Grevink, who is a PhD student at our group, and Giorgia Romagnoli, who is an associate professor. So I'm Theo Offerman. Let me clarify, like Ivan said, I'm from economics, so I'm very excited to present here, but this is not what I usually do, right? So you're not my typical audience, but this makes it more interesting to me, get your feedback. But what I'm hoping to do is that I try to get the speed at the right level, but if I go too fast or too slow, then please interrupt me. So that's a couple of things about myself. So I'm, like Ivan said, I started being very interested in game theory. So game theory is about the interaction of rational agents, or you could also think of them as rational machines. And I was really captured by the beauty of the theory. And also, you know, that you know, if this works, it can work to explain any situation with, or behavior in any situation with strategic interaction. But so then when I started doing my PhD, I was interested in seeing the predictive ability of the model. So I started doing experiments and confront the predictions of game theory with what we saw in the lab. And I was a bit disappointed, right? So then I moved towards behavioral economics, taking cognitive limitations of people seriously, social preferences seriously. And that's the background of my work for a long time. But recently we also got interested, like all of you are, in AI and AI-mediated behavior. And now I'm thinking, you know, this is my first project, so my first tip into the waters, but I'm now thinking that where I come from, you know, so if you look at how people's behavior changes when they interact with AI, I think that quite a bit their behavior may move towards rationality again, right? So in this project, we're looking at communication, and we look at a variant of communication that was traditionally considered cheap talk by game theorists. So cheap talk shouldn't affect the predictions of the game, because, you know, everybody can say that they are nice and kind, you know, but why trust people to do so? And we knew from experiments where people don't have interaction with AI, that actually what was considered cheap talk by game theorists was not cheap talk for real people. Right? So real people don't like to break their promises. They often make promises to cooperate, and they don't like breaking their promises. And so for humans, cheap talk seems to be not cheap. But now when they interact with AI, we may move into the direction of that is actually predicted by game theory. And I think, so this is not, I think, the only application where this will happen. I expect it to happen also in other cases. And another interesting application, but maybe that's more for the future, is that I think that when agents have access to AI, maybe they are able to forecast the preferences of other people. Right? So that's an assumption in traditional game theory. Games with complete information. Now we have relaxed that, and we look very much at Bayesian games, so it's incomplete information. But I think that if people have access to AI, they may be better able to predict other people's preferences and other people's behavior. And that could also shed a different light on game theory. So that's where I come from. So today we're going to look at large language models, and in particular to ChatGPT, and what that does to a literature in behavioral and experimental economics that shows that communication is key in trust and trustworthiness. Right? So this is not only in trust games. So I'm going to focus on the trust games. I'm introducing it in a few slides. But it's also, if you look at people's behavior in prisoner's dilemma, the most important variable that affects people's behavior in prisoner's dilemma is communication. And so if you let people communicate in a one-shot prisoner's dilemma, on average, their cooperation behavior moves from 20% to, say, 80%. Super large effect. And that's mostly mediated by people making promises in their communication. Something similar is happening in trust games. And what we see, for instance, that if people communicate in a trust game, if their communication involves a promise, then they get to the cooperative outcome in about 65% of the cases, whereas if their communication does not involve a promise, it only leads to 25% of the cases. So also in the trust game, communication is thought to be super important. And the central question that we're going to ask in this paper is whether AI mediation will affect the perception of and the commitment to the messages that we exchange. Before I continue, I'm not going to do a literature review. There is a literature review in the paper, and I'm very aware that many of you, IAT, for instance, has done very important related work. We discussed that in the paper. Happy to discuss it afterwards, but we're not going to do it here. So if you look at ChatGPT and you feed it with a trust game and you ask it to write a message, then there's a strong tendency towards suggesting promises. And like I already said, that if people don't have access to large language models, so that is all so the trust game that I'm going to discuss has had many applications. Many people have investigated it. They all didn't use large language models. And it was seen there that promises are a super strong signal for trustworthy behavior, right? So people that made a promise often kept their promise, and them making the promise was a super strong signal of their intention to cooperate. So there could be upsides and downsides of using a large language model. So an upside could be maybe people realize that promises are a good idea, and much more than they would on their own. So maybe they're going to make more promises. It may also increase message quality. Right? So sometimes people are a bit quick and fussy when they write a message, and maybe a large language model like ChatGPT does a much better job. There could also be some downsides, and the downside is decreased commitment. Right? So maybe if I copy a message from ChatGPT and it contains a promise, maybe I don't feel committed to following up. You know, it was ChatGPT that did it, but maybe I don't have to feel bad about myself if I deviate. And the other thing is that it might also be that on the receiver side of the message, people become more skeptical about the message, right? So those are two forces that could work in the other direction. And so ex ante, it's maybe not so clear what a large language model does to trust and trustworthiness. So the specific questions that we're going to ask in this paper is, does access to ChatGPT have an overall effect on trust and trustworthiness? Does it lead to more promises being made? Does it lead to a deterioration of the signal value of promises? And finally, do people feel less committed by a promise copied from ChatGPT? And in addition, does rewriting the message after affect the rate at which the promises are kept? Right? So it could be that if I just copy a message from ChatGPT, I don't feel committed to it. But maybe, you know, if I take the message and then start rewriting it, maybe it feels like my own, and maybe I feel committed. Right? So those are the things that we are looking at in this paper. So here I come to the design, and this is the canonical game by Chalmers and Duffenberg. It's a trust game, and it's used in many, many papers. So in behavioral economics, we tend to have a rather narrow view on trust and trustworthiness. And I'm going to stick to that narrow definition, right? And we acknowledge in the paper that in many fields a more broader definition is used. But so when we think about trust in experimental economics, we think about the actor choosing an action that potentially leads to a benefit of both players. Right? But then if the truster takes this trusting action, he makes himself vulnerable to being exploited. Right? So you create something that is potentially beneficial to both players, but if the other side is behaving opportunistically, in the end, you're going to be worse. So that's happening here. So in is the trusting option, out is the not trusting option. So if they, so in experimental economics, let me start there. In experimental economics, the field was developed by Vernon Smith. He got a Nobel Prize for his contributions, and he was emphasizing strongly that games need to be incentivized. And then if I talk to my fellow economists, they tend to believe that behavior is more insightful than people talking about what they do. Right? So often exposed talking is people want to be a little bit more nice about themselves than if they act in a certain way and it's really costly to them, right? So that's why, and I think maybe that was a little bit exaggerated by the early contributors like Vernon Smith, but that's where I come from. And that's also why we incentivize the game. So if you're the A player, if you don't trust, you choose the action out, and then the game is finished, and you get €5. So the first payoff in the seller's first mover's payoff, or A player's payoff. The second number is B player's payoff. And both of you get €5, and the game is finished. If you choose in, that's the trusting option, then B can be trustworthy. He's trustworthy if he rolls. He's not trustworthy if he doesn't roll. If he doesn't roll, then first mover gets 0. Is exploited, and second mover gets €14. But if he rolls, then there's a chance move, and it's a die roll with 1 out of 6, the outcome is 0-10, and with 5 out of 6, the outcome is 12-10. So in expectation, the outcome is 10-10, and the reason why Chalmers and Duffenberg had this feature of the game is they wanted to make it a little bit hidden whether B player was trustworthy or not, right? So it can happen that you end up with 0, but actually this came about by you rolling, and then there was something unfortunately happening, right? So yeah.
Does this mean that player doesn't see player B's payoff?
He doesn't see player B's payoff. That's correct.
Otherwise, they do.
Yeah. No, he does see player B's payoff. No, you're right. Thank you. Yeah, he doesn't know player B's payoff. He only sees his own payoff. So he doesn't see his move. He only learns this is the outcome, right? So you may get the bad outcome, but it could be that the other side was still trustworthy, and it was not. Was not. Right. So I think that this part of the game is not crucial, right? So they say that it's nice because it describes some contracts or incomplete contracts in the real world. We don't have a strong view on that, but we want to be consistent with the literature on which we base this. So we're going to do an experiment, a laboratory experiment with 320 participants, 160 pairs in total. So it's the trust game that I just described. That is on the right-hand side, and we're going to do a strategy method. So strategy method means that for player B, we're going to ask player B to choose between roll and don't roll without yet knowing whether player A chose out or in. And we do that because that way we get more data, right? Because it's a bit sad if player A chooses out, then we would never see what player B would choose. This is explained to the participants, and they know that player B's choice or strategy is going to be implemented automatically if player A chose in. So in that sense, it's incentive compatible. That's a strategy method. Then we have two treatments. One is what we call the communication treatment. So the communication treatment is a standard communication treatment that's being done in this whole literature, which means that B player can send a message to A player prior to the game, and he can write anything in this message. Right? So he can talk about the weather if he wants to, but he can also make a promise, right? And the promise would be something like, hey, A player, if you choose in, I promise that I will follow up by roll, and then in expected terms, we both will be better off than when you choose out. So this is the treatment that was investigated a lot of times, and then we're going to compare to the GPT treatment in which players are also allowed to write messages, but now B player has access to using ChatGPT-4, right? And both players are aware of this possibility. So yeah, the GPT treatment gives B players optional but full access to GPT-4. So player A is aware about the access. In GPT treatment, player A is aware about GPT access, but he doesn't know whether B accessed GPT or not. That's never communicated. Player B, so we did this study a few months or half a year after GPT was introduced, and we're running it with university students. So maybe not all the students are aware of ChatGPT, and that's why we gave them some prompts that they could choose, but we didn't force them to choose them, right? So we have run a pilot study with 10 people, and we asked them, if this were the game, and you can use ChatGPT, what is the type of prompt that you would enter? And we communicate those to the B players. They can use them, they can also use other prompts. And before the game starts, or before the communication starts, what we already did was we preloaded the instructions of the game, the same instructions that the participants got, into ChatGPT, and we already let ChatGPT make write a first message. Right? So if they access ChatGPT, which is something that they choose, they can also avoid that. Then if they access it, then they see this first proposal by ChatGPT, and then they can, if they are happy with the message, they can keep it, but they can also interact with ChatGPT by adding prompts, and prompts like this, but also their own prompts, right? So ChatGPT, at least the one, it's ChatGPT-4, but it tends to be a little bit on the formal side. So one prompt could be, I would like the message to be a little bit less official as well as shorter. But then there were also participants that thought that, maybe the opposite should happen, right? More substantial arguments should be added and everything should be made more theoretical. This I already said. And yeah.
About the previous slide on GPT use. So just to understand, so you don't observe the conversation that participants have?
We do.
You do, okay.
Yeah.
And do you elicit beliefs from player A about the use of GPT?
Yeah, we do.
Okay.
Yeah, we also do that.
You come to this.
Yeah, I was not. Yeah, so we measured A players exposed. We measured A players' belief that B player used ChatGPT, and we also measured a couple of other things at the end. We measured both players' risk aversion, and their social attitude, their cooperativeness, and their attitudes to AI.
Yes, just wondering because nowadays at least probably the new brand is not such a clear, but reading papers from students, let's say, right? There are always those words that pop up they use GPT-4 or something like this, right?
Yeah.
And it's delved into the ever-evolving realm of economic theory.
Yeah.
This gives you a signal that someone uses GPT or not, right? I was just wondering if you see.
Yeah, so we see some of that. So people, if you want, you can really quite easily avoid ChatGPT, what like the students can nowadays. Like, so you can make it sound very human, but on average, our participants did not.
Okay.
Right? So whether or not ChatGPT was used is predictable to some extent.
Okay.
Right? I think so. Every 10 percentage points that the belief was increased that ChatGPT was used, 3% more likely was it that ChatGPT was actually used in an OLS revision. So they are able to anticipate that ChatGPT was being used to some extent. Yeah. So we look exposed, so we have all the conversations with ChatGPT, but we also have the message that was sent to the A player, and we let the message that was being sent to the A player, we let that be encoded by 3 coders, and in particular, we wanted them to code whether a promise was involved, right? And a promise could be either something that was very explicit, like I promise to do this, but it could also be something which didn't use the word I promise to do this, but which describe this in other terms. So it could be like a clear statement of intent. And in those cases, the statement was coded as involving a promise, right? And here we use the procedure of Chen and Hauser, and we're just being consistent with the literature. So we have 3 coders, and mostly they agree, but if they didn't, then we take majority. So they could, if there was no promise, then it could happen that some people, not so many, did not send any message. They just left it blank, but others were basically chit-chatting without leaving a promise. So those are the 3 options. Now, if everything is clear, then I'll move to the results. So the first question is, does these access to ChatGPT have an overall effect on trust and trustworthiness? And I started by saying that there's opposing forces potentially, and we see that in total not so much is happening. Right? So we see that ACE-in rate, that's the trust rate, is not significantly different between communication treatment and ChatGPT treatment. And the trustworthiness rate, or the role rate, is also not different. Also, overall, the combined outcome of in and role, the cooperative outcome in the trust game, was not significantly different between the treatments. So now we ask a question, does B's GPT access affect the decision to include a promise in a message? And here we see a clear effect. So B players in the GPT treatment were almost 19 percentage points more likely to send the promise compared to the communication treatment. And this was significant. And then the question is, so they do send more promises. Then the question is, does these access to ChatGPT deteriorate the signal value of promises? And here we get the following results. So participants in the GPT treatment are almost 22 percentage points more likely to keep their promises. That must be the other way around, right? No, they are less likely. Oh yeah, I also write that. They are 22% less likely to keep their promises. This is as expected. And interestingly, this is not yet completely anticipated by A players, right? So all A players are a bit gullible, so they are not making a clear distinction between the promises made in the original, in a communication treatment, and promises made in ChatGPT treatment. And I talked this morning to Annemarie, who has a project with Ivan, and I think they saw something similar in their project about people's apologies. Yeah, exactly. So there is an effect, but people on the receiving side do not yet completely anticipate it. Yes.
I mean, it's probably fun out for you didn't do this, but like, of course, it would be interesting here to see this unraveling if you do this in a repeated game.
Repeated game, I completely agree, right? So we don't have a repeated game setting, and we discussed it, and maybe we should have done it, right? So I can imagine that if you do this 5 times, and you give people feedback in between, then that this will unravel. And I also think, you know, so this was done a few months after the introduction of ChatGPT, and those are, I think, that's on one side a bit sad that these results may be a bit temporary, but on the other hand, I think it's much of the work on interaction between humans and the AI, right? So things are changing, right? And maybe if we do the same experiment in 5 years, results will be quite different. And I think that maybe that's what we should do, right? And not only this paper, but also other papers. Does the access to ChatGPT deteriorate the signal value of promises? And here we see that following a promise, the joint outcome in role occurred 68% of the time in the communication treatment, but only 47% of the time in the GPT treatment. And so here we do see deterioration in outcomes. And I think that the most interesting statistics are on this slide. So suggestions by ChatGPT often include a promise, and those tend to be copied by participants, and in particular by those who intend to cheat. So what is a bit remarkable about data from communication studies without large language models is that people who intend to cheat on their partner often do not make a promise. So they often don't make a promise. You let these people interact with ChatGPT. Now people that intend to cheat think, okay, it's actually not such a bad idea to include a promise. So B players that don't roll in the communication treatment only include a promise in 30% of the cases, but in the ChatGPT treatment, they include it in 80% of the cases, which means that a promise in the communication treatment is really a very clear signal, right? So now if you receive a promise in traditional communication, this is very informative about whether the person is going to be trustworthy or not. But now with the GPT treatment, it's not informative at all anymore, right? So I think that this is, as far as I'm concerned, maybe the most interesting statistic. Yeah.
How do you assess it includes a promise or not?
So what we do is we have 3 coders, so that's not us, and they were unaware of the hypothesis that were being tested. We give them all the conversations, all the messages that were sent, and we ask them, so we tell them how we define a promise, and then we ask them to rate whether the promise is included in the message or not. Very often, the 3 coders agree. If they don't, we take a majority. How do we define it includes the promise? So then it's either we say that it has a promise if the statement literally says, I promise to do this. But we also do it, if it's not a literal promise, but a clear statement of intent. So if the word promise is not used, but it's clearly implied that after the person will follow up by law. For example, somebody saying, I would not do you any harm if you choose me. Right? So then you don't use the word promise, but essentially you're saying the same thing. So we also look at, yes. Sorry, say that again. Well, I don't know that from the top of my head, I should, but I think most people, or how many people send their promise? Is that what you ask? Or is it like empty versus blank? Yeah, I think not so many, but I don't know that from the top of my head. We should look at that. Thanks. We also looked at the extent to which people were rewriting the suggestions of ChatGPT. And the way that we measured this was we were using a method, text analysis, that was used by or introduced by Huang in 2008. And that is called the cosine similarity model or score. And so what this method does is it looks at the message that was actually being sent to the other side, and it looks at all the substantial words. So unsubstantial words are words like conjunctions or words like stop words. They are taken out of the message. And so you have the actual message that's being sent, and that's represented by a vector. So a vector of words that are contained in the message. And then we look at the suggestions that were generated by ChatGPT, and we also let them be represented by a vector. So also there, you can see which words were used and whether the words in the message of ChatGPT coincide with the words sent to the player A. Right, so those are, you have 2 vectors. If a person has exactly copies the words, then the angle between the vectors will be 0, and then the cosine will be large if it's very similar, and opposite, right? So if you don't use ChatGPT at all, then the cosine will not be 0 because accidentally you may use similar words, but it will be much less. But so this is the method that we use, and it's what we use here is that we know where some people did not access ChatGPT, right? So they got this option to access it, and they didn't do it. But then we have also people that did access it, but then some of them, just briefly looked at it, and then they went away, right? So they maybe were curious, and then they thought, okay, this is not my thing. I'm going to write my own message. But we want to identify the people that actually used ChatGPT from those that maybe just looked at it but wrote their own message. So what we do is we look at the maximum similarity score of the people that did not access ChatGPT, so that ranges between 0 and 25. So if you have a score of 25, then it's still pretty likely that you did not use ChatGPT. So here we use that as a cutoff to separate people from who looked at ChatGPT and actually copied it to some extent to various extent, and people that looked at ChatGPT but didn't use it, right? And we're interested in the people in need. And we want to know whether the extent to which they read the message, whether that correlates with their decision to stick to their problems. And that is what we see. Yeah.
Just one question.
Yeah.
So these are all people that had access to GPT.
Yeah.
So did you also do compute the similarity for the ones that didn't have the opportunity? Yes, because here you have a little bit of selection. But
there we don't see, in the other treatment, they didn't have access to.
Yes, but you can see how similar this message would be to the GPT one.
So,
and if it's similar to the one that didn't access.
So you mean that exposed, we could enter the message in GPT and look at the initial message?
Because the one, so maybe I didn't understand exactly. You look at how similar is the final message to the first message.
To the best fitting message. I should have said that. So they have multiple messages which received from ChatGPT. We compute the cosine similarity between each of these messages, and we take the maximum one. So assuming that and usually that's the last one. Right, so they interact with ChatGPT until they're happy, and then usually they copy the last message and rewrite that to some extent.
Okay, but so for the one that didn't access, there is the first message.
For the ones that didn't access, then it's the first message. Yeah, that's correct. Yeah,
thanks.
Okay. So here we see. You can see the picture. So the most interesting part is the one above the similarity cutoff range. And so these are the people that we think use ChatGPT. And then this is like a regression line. This is if you have a non-parametric line. We see clearly that if people become more similar in the message that they send compared to the message that they receive from ChatGPT, that declines the probability to roll. That's on the vertical axis here, to be trustworthy. Right. So the more they just went along with the suggestion of ChatGPT, the more they were inclined to forget about the prompts and to not roll. Well, if they reworded more, they felt more like, okay, I maybe have to stick to this. Yeah.
Did you think about like treatment variation in the sense of like manipulating people to alter their message more? So like an information type of treatment that I will tell them you are perceived as trustworthy. Tailor your message isn't split.
So you want to get to more causal evidence?
Yeah, exactly.
I think that's an interesting possibility. We didn't do that, and I agree. This is correlation. Yeah.
Do you look into things that you explored, such as risk preferences or such, whether
Yeah.
they are predicting this?
Yeah. So I didn't discuss it here, but for everything that we do here, we also have regressions. So we look at whether people's risk attitudes or social value orientation or their attitudes to AI, whether that changes their decision to trust or to be trustworthy. It does, right? So people that are more risk averse tend to be choose trust less often, but it doesn't affect the effects of the treatments. So none of the results that I discussed today is going to be affected if we have an OLS regression and we include all these measurements at the end as controls. Yeah.
Follow-up question.
Yeah.
I was thinking also from the direction that you could use them to see who selects and to actually sort out.
Rewriting, you mean? Or, yeah, that's an interesting. I think we didn't do that. I like that suggestion. I know I'll write it down. That's an interesting one. We didn't do that yet. I'm pretty sure. It's a good one. So I come to the end. So the findings that we have is that there's no overall effect on trust and trustworthiness and on outcome in a role. But we do find effects of promises. So there's lower trustworthiness and also fewer in-role or cooperative outcomes when promises are being made, conditional on a promise being made between ChatGPT and the normal way of communicating. What I find quite dramatic is the evidence. So it's not a small effect, it's a huge effect that promises are no longer a reliable cue of whether people are going to be honest when communication is AI assisted. And so dishonest people include a promise much more frequently when they have access to ChatGPT than when they don't, right? And that really, that really unravels the value that communication had in the past when people didn't have access to ChatGPT yet. So this is pretty fast, right? So this is already a few months after the introduction of ChatGPT. The experiment was run between June 23 and October 23. And already then you see that this happens. So our conjecture is that in the future, introduction of large language models will encourage people to find other ways to communicate. And could be that people are starting to add more value to face-to-face communication. There's an old paper by Planck, Gilovich, and Reagan that really shows in a business dilemma context that if you let people talk for 10 minutes, they are considerably better able to distinguish people that are going to cooperate from those that don't, right? So maybe that will be in the near future a way to separate cheaters from non-cheaters. Much more than that. And that's the end. Thank you.